Hello students, today we start with the second part of chemical reactions and equations. Balanced chemical equations. Why do we have to balance equations in the first place? In 9th standard, if you remember, we had studied about law of conservation of mass. What does law of conservation of mass say? It says that mass can neither be created nor destroyed in a chemical reaction. That is, the total mass of elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, the number of atoms of each element remain the same before and chemical reaction. So what does that mean? Number of atoms of a particular element on the left hand side should be equal to the number of atoms that is present in the reactants on the right hand side. Now let us take this example, magnesium plus O2. Here the reactants is Mg and O2 and the product is MgO. So is this equation balanced? No, this equation is not balanced because for oxygen you have here 2 atoms but in the product you have only 1. So how do we balance this equation? Can we write 2 over here? No, we cannot write 2 like this. This becomes wrong. Whenever a chemical equation is given, we will maintain whatever is given as such, and writing any number in these places is wrong. You can only write the numbers in the coefficient place. Okay, now let me erase this. So how do we balance this equation? We balance this equation by adding 2 as the coefficient of Mg. So here you have 2 Mg, right? And here you have 2 Mg. For oxygen, again you have 2 atoms of oxygen here, and this 2 is for both magnesium and oxygen. So this 2 has 2 Mg as well as this 2 is for the oxygen atoms too. So you have 2 Mg here, 2 Mg, 2 O here and 2 O here. So this is the balanced equation. So let's see another example for balancing equations. The experiment that we have seen before, zinc plus sulfuric acid gives rise to zinc sulfate plus hydrogen. So what form of equation is this? This is a word equation. What have I written now? Zn plus H2SO4 gives rise to ZnSO4 plus H2. It is the same previous equation, but it is the chemical equation. Hope now you have understood what is the difference between word equation and chemical equation. So how do we check whether this equation is balanced? Now let us consider the different elements and their number of atoms on the left hand side and the number of atoms on the right hand side. Now first you see the zinc. Here zinc, how many atoms are there? 1. And on the right hand side, how many are there? 1, right? So the number of atoms of reactants of zinc element on the left hand side is 1, and the number of atoms of zinc on the right hand side is 1. Now let us see the next one, which is hydrogen. So for hydrogen, the number of atoms on the left hand side is 2. Here again we have 2 atoms of hydrogen, and on our right hand side we have 2. So 2 on the left hand side and 2 on the right hand side. So the next element, which is sulfur. Sulfur, here you have 1 second, let me erase the previous ones. Okay. Now we'll see sulfur. Here you have sulfur 1 atom on the left hand side and 1 atom on the right hand side. So sulfur, you have 1 atom on the left hand side and 1 on the right hand side. Now coming to the next one, which is oxygen. Oxygen, you have 4 over here and 4 on the reactants, on the product side too. So here you have on the left hand side 4 atoms of oxygen and 4 atoms of oxygen even on the right hand side. So is this equation balanced? Is this equation balanced? Yes, this equation is balanced. Let's see another example. Fe plus H2O gives rise to Fe3O4 plus H2. That is, iron combines with water to form ferric oxide and hydrogen. So is this equation balanced? If you see here the first element Fe, on the left hand side you have 1 Fe and on the right hand side you have 3. So from here itself we can deduce that this equation is not balanced. So your step 1 for balancing the equation would be to first draw the boxes around each formula. Do not change anything inside the boxes while balancing the equation. That is, as we had discussed before, whatever equation is given, we are not going to change anything over there. So our step 2 for balancing the equation would be listing the number of atoms of the different elements present in the chemical equation Fe plus H2O gives rise to Fe3O plus H2. So when we list out, we see that the element Fe has 1 atom on the left hand side and 3 atoms on the right hand side. The element H has 2 atoms on the left hand side and it has 2 atoms on the right hand side. And oxygen has 1 atom on the left hand side and 4 atoms on the right hand side. So obviously this is an unbalanced equation. Step 3. To start balancing, first we have to consider the compound that contains maximum number of atoms. This compound can either be a reactant or a product. Second, in the compound that you have chosen, you have to select an element which has maximum number of atoms. So in our equation, we see Fe3O4 is the compound that contains maximum number of atoms and oxygen is the element in that compound that has maximum number of atoms. So if we represent the number of atoms in a table form, we see initially in the reactants we have 1 oxygen and in the products we have 4 oxygen atoms. And to balance, we need to have 4 oxygen atoms in the reactants and 4 oxygen atoms in the products. So this is the equation, and now we were discussing that oxygen is having 4 atoms on the product side and it is having 1 atom on the reactant side. So can we write H2O4 for balancing this equation? No, we cannot write. As I told before, we're not going to change whatever is already there and we're not going to add the numbers here as subscripts. Can we write as this? No, we cannot write even this way. So then how do we balance? I told you we can write it as coefficients. So if you're writing 4H2O, then this is right. So we can write it as 4H2O, right? So here we have oxygen atoms, 4, and here we have O4. So this is a partly balanced equation. So we still need to balance the other atoms. So our equation, which was like this, has become like this. That is, we have added 4H2O to balance the oxygen atoms. Now step 4. We have balanced oxygen atoms previously. Now we have to balance the rest of the atoms. So let's pick hydrogen. So if you see equation 2, you have in the reactants 4 into 2, that is 8 hydrogen atoms, whereas in the products you have only 2. So to balance, we need 8 on the reactant side and 8 on the product side. So what are we doing? We are adding 1, 4 over here to balance the hydrogen atoms. So is this equation balanced? No, the equation is still not balanced. So we have come to this third equation now. We have balanced the oxygen atoms and we have balanced the hydrogen atoms. So what is remaining? Iron is remaining. So in step 5, we'll pick up the element that is still not balanced. So in our case, it is iron. Now atoms of iron, initially, here you have in the reactants 1, but in the product we have 3. So for balancing, we need to have 3 on the left hand side and 3 on the right hand side. That is 3 in the reactants place, that is 3 atoms of iron in the reactant side and 3 in the product side to balance the equation. So how do we balance? Suppose we are adding 3 over here, then we have 3 atoms of iron on the left hand side and 3 on the right hand side. So the number of atoms on both the sides of the equation is balanced. So our final equation is the fourth one. We have 3Fe plus 4H2O, which gives rise to Fe3O4 plus 4H2. So step 6, we will finally count each element, that is the atoms of each element on both the sides of the equation to check if it is completely balanced. Now if we take a final equation, here we have iron, 3 atoms. On the left hand side we have on the right hand side we have iron 3 atoms. Hydrogen we have 8, and on the right hand side we have 8. Oxygen we have 4 on the left hand side, and on the right hand side also we have 4. So this equation is a balanced equation. So this method of balancing equation is called as hit and trial method. Step 7. So what do we do in the step 7? We have balanced the equation. Now we have to state what physical state each of these reactants and products are. So what are the notation used for different physical states? For gaseous we use G, for liquid we use L, for aqueous we use AQ, and for solid state we use S. So what is AQ? AQ means that the reactant or product is present as a solution in water. I'll repeat. Aqueous means that the reactant or product is present as a solution in water. So our final equation will look something like this. Here for water we are using G. Why are we using for water G? Because water is used in this equation as steam, that is in the gaseous form and not in the liquid form. So here carbon dioxide in gaseous form combines with hydrogen again in gaseous form at 340 atmospheric pressure to give methanol. In the second equation, you see carbon dioxide which is in aqueous form combines with water which is in liquid form in presence of sunlight and chlorophyll to give glucose in aqueous form, oxygen in aqueous form, and water in liquid form.